Hello guys, welcome back to my channel. I hope you are all doing good. Today we are going to see another problem. Leetcode problem number 136 single number. Let's see the problem statement. Given a non-empty array of integer nums, every element appears twice except one. Okay. We need to find that single element. Okay. So we have one constraint here. They are asking us to achieve this in linear time complexity followed by the constant extra space. Okay, so let's see an example. So here in example 1 we have 2 2 1. So the output is 1 because 2 occurred 2 times. So if we see the example 2, we have 4 1 2 1 2. Here 1 occurred 2 times, 2 occurred 2 times. Of course the answer is 4. If only one number, we have to return that. Okay, so let's see how we can solve this problem by different approaches. So let's assume we have this input array. So nums, okay. So we have 4, 1, 2, 1, 2, and we know the output should be 4 because it occurred only one time. So let's see in how many ways we can solve this problem. Uh, the first thing is we can leverage the hash maps here. Hash maps, okay. So how we can solve this problem using? So let's take this is my hash map, okay. So we can count the number of times each number occurred. Okay, and we will return the number which occurred exactly one. So what do you mean by that? So we start iterating from this input array. Okay. So 4, 1, 2, 1, 2. Okay. We count 4. So 4 is occurred 1. So the key value pair will be something like this. This is the actual number, and this is occurrence occurrence. So next to 2, sorry 1. So this we done. So 1 comma 1, 1 occurred at this point of time only one time. So then we have 2, 2 comma 1. Okay, then we have 1. So since 1 already occurred one time, then it will become now 2. Okay, so then 2, since 2 also occurred once, then it will become 2. Okay, so now we have a hash map where we can see 4 is the one which occurred only one time. Okay, 4 is the one which occurred only one time, and we can simply return this one. Okay, but let's see what is the time complexity and space complexity with this approach. So time complexity is going to be big of n because we are going to travel only one time. So space complexity is going to be big of n because we are using this hash map as an additional data structure to solve the solution, right? So that is a drawback with this approach. Okay, because in problem they're asking us to achieve in big of one space complexity. Okay, so let's see the second approach. Okay, second approach. So what you can do? So sorting using. Okay, what do you mean by that? So let's start the input array like this: 1 1 2 2 and 4. Okay, and check each its adjacent element. Okay, so let me zoom it. Yeah, so here if you carefully observe, so I have a sorted. So let's take I am at this position, so compare its adjacent one whether it has a one or else not. Then come to 2, let's check its adjacent. Then come to 4, let's check its adjacent. So here you're going to find your answer. Okay, 4. But what is the time and space complexity with this approach? With this approach, so time complexity is going to be big of n log n because you are performing sorting on this. But space complexity is going to be big of 1. So again, the issue with the time complexity with this approach. Okay, so how we can solve this then? So let me have a line here. So I hope you people are aware about this XOR operator. Okay, so always remember whenever you have a problem where you need to find the missing duplicate, okay, missing number or a duplicate. Okay, so whenever you encountered a problem like this, always think about this XOR operator. Okay, so let's see how what are the properties of XOR. So we all know, so when bits are same, it is going to be 0. When bits are different, then it's going to be 1, right? So what do you mean by that? 0 0 will become 0, 0 1 will become 1, 1 0 will become 1, 1 1 will become 0, right? This is the XOR property. So let's see how we can solve this problem using XOR. So if we carefully observe, so we have 4 1 2 1 2, right? Right. So using XOR, okay, you think something like this: 1 XOR 1 XOR 2 XOR 2 XOR 4. Okay, so what is the bit? I mean, a binary representation of 1. Let's 0 0 1. Okay, and what is this? 0 0 0 1. So what we are going to get? Since all bits are 0, we are going to get 0 0 0. That is nothing but 0, right? Then come to this pair 2. What is the binary representation? 0 0 1 0. Since all bits are same, then we are going to get again 0. That is nothing but 0. Then after this operation, what we are going to have? We are going to have 0 XOR 0 XOR 4, right? So then look at this pair. So 0 0 0 0 and then 0 0 0 0. Since all bits are equal, then again it is going to give me a result of 0. Okay, and finally I have 0 with 4. So always remember in XOR this property also, I mean, you can imagine from the previous diagram. So 0 with any number will become that number. Okay, let me explain you what I mean by that. So 0 0 0 0 representation and 4 representation is 0 1 0 0. So what we are going to get? Bits are equal 0, bits are equal 0, bits are not equal 1, bits are equal 0. Then you can clearly see here the binary representation of 4 it is, right? Then it is going to return the 4. So that's all the problem. So what is the time and space complexities with this approach? Time and space complexities. So the time complexity is going to be big of n because we are traversing through all the elements one time. But space complexity is going to be big of 1, right? Because we are not using any additional data structure to process this problem. Okay, so I hope you got the problem. So let me jump to the lead code. Let me solve here. So I need a result. Okay, int result equal to 0. Okay, I am going to iterate through the numbers for int I in nums. Okay, so I'm going to do result XOR I. Okay, then at the end I'm going to return result. That's it. So let me submit. Yes, it got processed. So let's check a test case by our own, which we solved there. So 4 comma 1 comma 2 comma 1 comma 2. Great. Let me run it. Submit. Yes, it got submitted and we are able to achieve this problem in the time complexity of big of n and space complexity of big of 1. Okay, thank you for watching my video. Please do subscribe for more videos.